Hi everyone, in today's video we will be learning about ratio. In primary school, we have learned about equivalent fractions as well as equivalent ratios. Let us do a very quick recap. In the fractions 2 over 4 and 6 over 12, we can see that they are equivalent fractions because from 2 to 6 we can multiply by 3 in the numerator, and from 4 to 12 in the denominator we can also multiply by 3. So in the numerator and denominator, we multiply by the same factor. Then, in the fractions 2 over 4 and 1 over 2, they are equivalent fractions as well, because in the fraction 2 over 4, or rather in the numerator 2, we can divide by 2 to arrive at the numerator 1. And from the denominator 4, we also can divide by 2 to achieve a denominator of 2. So therefore, 2 over 4 is equals to half when we divide by the same factor in the numerator and the denominator. So likewise, since we have seen that fractions and ratios have equivalent expressions, so in the ratio 2 is to 4 and 6 is to 12, which is the same as this fraction over here. From 2 to 6 we can multiply by 3, and 4 to 12 we can also multiply by 3. So therefore the ratio 2 is to 4 is the same as 6 is to 12. Likewise, for the fractions 2 over 4 and 1 over 2, we also can see its equivalence in the ratio form, which is 2 is to 4 being equals to 1 is to 2. So from 2 to 1, we also divide by 2, and from 4 to 2, we also divide by 2. Therefore, we have learned about equivalent fractions and equivalent ratios previously. Let us now take a look at simplifying ratios. In this question, we want to simplify the ratio 1 and 2 over 3 is to 5 over 6. So because the quantities in this case are in fractional form, what we need to do first is that for 1 and 2 over 3, we could re-express it into its improper fraction form, which is 5 over 3. And we notice that we have 5 over 3 is to 5 over 6. In the denominators of both quantities, they are actually different. So we have 3 in our first quantity and 6 in the next quantity. So what we could do is to multiply across both quantities by the same lowest common multiple of the denominators. And in this case, with the denominators 3 and 6, the lowest common multiple of 3 and 6 would actually be 6. So we multiply both quantities by 6 in this case. The reason for us to do so is so that we could change the quantities into integer forms, okay, such that it will be easier to manage, because in ratios our quantities should be integer quantities. So when we multiply by 6 on the left quantity, we will get 10, and when we multiply by 6 on the right quantity, we will get 5. However, 10 is to 5 is not at its simplest form, so we can simplify it further by dividing by 5 across both quantities. Now you may be wondering, is there an easier way to actually go about simplifying ratios since we have access to a calculator? Alright, there is a way to actually simplify our ratios. So let me play this video now to actually show you how to simplify ratios using a calculator. However, do take note that the calculator is only usable for us to simplify ratios when there are two quantities in the ratio itself. It will not work when there are 3 quantities. So in our calculator, what we will first do is to actually press 1 and 2 over 3 first. And because we know that 1 and 2 over 3 is to 5 over 6 is the same as seeing it as a fraction or a division in this case, okay, we can recognize that 1 and 2 over 3 divide by 5 over 6, and we observe that in our calculator what we will achieve is a value of 2, and it is a whole number 2 in fact, and a whole number 2 can be expressed as a fraction as 2 over 1. So therefore the equivalence of this, okay, is 2 is to 1. Okay, let's take a look at another example. So in this case, we have 0.12 is to 0.56. How do we go about simplifying this ratio then? Okay, so we follow the same principle as what we did when we had fractional quantities, we want to change our quantities into integer values first. And in this case, with 0.12 is to 0.56, what we could do is to multiply by 100 on both sides. Why is it 100? Because I know that for each 10 that I multiply with, okay, the decimal place will move to the right by one position. So therefore, in this case, since they are both two decimal places values, we can multiply by 100 in order to shift the decimal point to the right by 2 times. Hence, we will be able to get 12 and 56. So now that we have integer values 12 is to 56 already, we observe that they are not at the simplest form yet. So what we could do is to divide by 4 on both quantities in order to achieve 3 is to 14 to simplify the given ratio. So likewise, we are able to use a calculator to help us in simplifying this ratio. So we will press into our calculator 0.12 divide by 0.56. And then we observe that in our calculator, we get the value of 3 over 14. And we re-express this ratio over here, this fraction of 3 over 14 into our equivalent ratio form, and that will be 3 is to 14. Therefore, using our calculator, we could actually you can use it to help us to simplify this ratio 0.12 is to 0.56. We will now find and simplify ratios of quantities with units. So in this question, we have to find the ratio of 2 1/3 kilograms to 700 grams. In our ratios itself, the first important thing is that the quantities need to both be in integer values. And the next important thing is that both quantities have to be of the same units. So in this case, we observe that one of it is 2 1/3 in kilograms, the other one is in grams. So we actually need to do a unit conversion first. So what is easier might be to consider changing the kilograms into grams, and that could be done so by taking 2 1/3 to multiply with 1000. Then we will get 2333 and 1/3 grams. That is because 1 kilogram is equals to 1000 grams. So now that we have done the unit conversion, that means that with the given 2 1/3 kilograms is to 700 grams, we convert both into grams in units such that we are looking at the ratio of 2333 and 1/3 is to 700. So as mentioned earlier, our quantities must be in integer values. So what we will need to do is to actually change the 2333 and 1/3 into a integer value, and we can't change that alone. We can only do that by multiplying by 3 on both sides, or rather on both quantities, such that this will become 7000 when we multiply by 3, and 700 will become 2100 when we multiply by 3. So what we have just done is to multiply across by 3 to achieve integer quantities. Then we simplify our ratio by dividing by 700 on both quantities such that we are left with the simplified ratio of 10 is to 3. You may definitely use a calculator at this step over here, where we have 2333 and 1/3 is to 700. So we press our calculator, okay, 2333 and 1/3 divide by 700, and it will immediately bring to us a fraction of 10 over 3, which we can write in its equivalent ratio form of 10 is to 3. We now take a look at the next question on finding unknown in a ratio. So let's first take a look at part A. In part A, we are given that 4x is to 9 equals to 7 is to 3, and we want to find out the value of x. When we write it in this ratio form, it is actually difficult for us to manipulate or solve it itself. So what we could do is to re-express this ratio form into its equivalent fractional form. Since we know that 4x is to 9 can be written as 4x over 9, and 7 is to 3 can be written as 7 over 3, okay, it will be much easier for us to solve this because we know how to solve a fractional equation. Now that we are at this stage, in order to solve this, we are able to identify that on the left it is a single fraction and on the right it is also a single fraction. So we can cross multiply and achieve 4x times 3 equals to 7 times 9. And then we further expand it to get 12x equals to 63, and that will give us x equals to 63 over 12, where we bring this 12 over to the right, and therefore we have the answer of 5 1/4. Therefore, the value of x of this question is 5 1/4. We now move on to part B, where we are given 3:y equals to 3 square is to 2 square, and we want to find out what is the value of y. So similarly, we will re-express this ratio form into its equivalent fractional form, and that is 3 over y equals to 9 over 4, or at this point 3 square over 2 square. So 3 square over 2 square is the same as 9 over 4. Okay. So now that we have arrived at our fractional equation, we see that on the left is one single fraction, and on the right it is also a single fraction. So therefore we can cross multiply, and we have 3 times 4 equals to 9 times y, and that will give us 12 equals to 9y. So since our objective is to find out what is the value of y, we bring the 9 over to the left, and that is 12 divided by 9, and that will give us that y equals to 1 1/3. And therefore, to answer this question, the final answer is 1 1/3. Let us now take a look at a problem involving ratios of two quantities. So in this question, we are given that the ratio of the number of female participants to the number of male participants at a party is 4:9. If there are 30 more male participants than female participants, calculate the total number of people who attended the party. So we observe that the number of female participants is 4 units and the number of male participants is 9 units. Since the question said that there are 30 more male participants than female participants, what this tells us is that the difference of 9 units and 4 units, which is 5 units, is representative or corresponding to these 30 male participants. So we can write that 5 units corresponds to 30 male participants, or 30 participants in general. Since the question wants us to find out what is the total number of people, and the total number of people is representative of 4 plus 9 units, that makes it 13 units in total. So to find out what is the total units, okay, that will be 4 plus 9, that's 13. Hence 13 units will be 30 divided by 5 times 13, which gives us the value of 78. Therefore, to answer the question, the total number of people will be equals to 78. Let us now take a look at another question where we are given that Cheryl and Shufen each have a sum of money. The ratio of the amount of money Cheryl has to that of Shufen is 3:5. After Shufen gives $150 to Cheryl, the ratio of the amount of money that Cheryl has to that of Shufen becomes 7:9. We want to find out the sum of money that Cheryl had initially. So we do not know what is the amount of money that Cheryl and Shufen had at first, but then we know that the ratio of it is in 3:5. So the exact amount of money that they have will be in multiples of 3:5. Therefore, what we can say is that, okay, given that Cheryl has 3 units and Shufen has 5 units, we can write that Cheryl's initial amount of money, okay, is actually 3x, and Shufen's initial amount of money could be 5x. So they are in multiples of 3 and multiples of 5, given the initial ratio of 3:5. Because the question subsequently says that Shufen gives $150 to Cheryl, this would mean that Cheryl's current amount of money will be equals to 3x plus 150. Then Shufen's current amount of money will be equals to 5x minus away 150, because Shufen gave money away to Cheryl. In the next part of the question, it says that Cheryl has 7 units and Shufen has 9 units. What this means is that this 3x plus 150 to 5x minus 150 must follow this ratio of 7:9. But we know that instead of writing as a ratio, we can write things in a fractional form. So we can have 3x plus 150 over 5x minus 150 to be equals to 7:9 or 7 over 9, where in this case our numerator is Cheryl's amount of money and in the denominator we have Shu Fen's amount of money. So what we did is to express 7:9 into its fractional equivalence of 7 over 9. So now that we have a fractional equation, we know that we can cross multiply and achieve 9 times 3x plus 150 equals to 7 times 5x minus 150. So we could expand this equation and we arrive at 27x plus 1350 equals to 35x minus 1050. And in manipulating this equation, we get 27x minus 35x equals to negative 1050 minus 1350, which simplifies to negative 8x equals to negative 2400. And therefore, x is equals to negative 2400 divided by negative 8, which is equals to 300. Since now that we have found out what is the value of x, we need to keep in mind what the question wants us to find. The question wants us to find out the sum of money that Cheryl had initially. So the amount of money that she had initially is 3x, and therefore we need to find the value of 3x, which is 3 times 300, that is giving us $900. And therefore Cheryl had $900 initially. So earlier on we were looking at ratios involving two quantities. Now we're going to be looking at ratios involving three quantities. In this question we have x is to y equals to 11:8 and y is to z equals to 6:7. So individually there are two quantities ratios, and we want to calculate a ratio of x is to y is to z. Okay, so how do we go about doing that? Alright, so in this case, what we will first lay out is to write down x is to y is to z. Okay, put in the structure in place first. Okay, and then we put in our 11:8, which is the ratio of x is to y. And then in the next line, we put in our 6:7, which is the ratio of y is to z. Okay, so we observe that y is actually the common quantity over here. So because y is the common quantity between the two ratios that we have been given, we let y be the same number of units since it is the common part of both ratios. Alright, so what does it mean to have same number of units in this case? We look for the lowest common multiple, alright, of 8 and 6. So in this case, 8 and 6 has the lowest common multiple of 24. Okay, so we see that 8 needs to multiply by 3 in order to arrive at 24, and therefore we look for equivalent ratios of 11:8 such that our 11 needs to also multiply by 3 in order to get to 33. Okay, then likewise we do it with the second ratio. So 6 needs to multiply by 4 in order to get 24, and then we also multiply 4 to 7 in order to get 28. So we arrive at the ratio 33:24:28, and therefore that answers our question that x is to y is to z equals to 33:24:28. Okay, in case you are wondering, what if our quantity y over here, we do not choose our lowest common multiple? So for example, if you were to decide to choose 48 instead, the steps will still follow. So if we have 8 over here and we get 48 over here, that means we're multiplying by 6. So over here we also multiply by 6. Likewise, for the second ratio, we will be multiplying by 8 and multiply by 8. However, the final answer that we are getting likely requires some form of simplification. So in the event that you do not choose the lowest common multiple, you need to check through across all the three quantities and ensure that your ratio is in its simplest form. Moving on to part 2, in order to look for the ratio of x is to z, we rely on our answer in part I. So in part I itself, we see that the number of units for x is 33 and the number of units for z is 28. And therefore x is to z will have the ratio of 33:28. You may also want to take note that when we are trying to simplify any ratio involving 3 quantities or even more quantities, we cannot rely on the calculator for the simplification process. That's because we are not able to express a 3 quantity or anything that's higher, okay, than 2 quantities ratios as a fraction form. Okay, because fraction is limited to just 2 quantities in the numerator and denominator only. So our calculator will not allow us, or rather not be able to help us in doing our simplification process. Now we look at other problems involving ratios of 3 quantities. So this question looks a little bit similar to what we saw for Shufen and Cheryl earlier on. Okay, so in this question, we are given a sum of money again, and it is being divided among Bernard, Li Ting, and Yi Hao in the ratio of 9:8:7. After Bernard gives $25 each to Li Ting and Yi Hao, the ratio becomes 16:17:15. We want to calculate the amount of money that Bernard had at first. So let's look at the first statement. The first statement tells us that Bernard, Li Ting, and Yi Hao have the money divided amongst them in the ratio of 9:8:7. So we know that the amount of money will be in multiples of 9:8:7. So what we could say is that we let the amount of money that Bernard had initially be 9x, that Li Ting had initially be equals to 8x, and finally the amount of money that Yi Hao had initially will be equals to 7x. So it still follows the ratio of 9:8:7. Then, because Bernard gave $25 each to Li Ting and Yi Hao, that will mean that Bernard has $50 lesser now. So that means that the current amount of money, okay, that Bernard has now is equals to 9x minus 25 minus 25, and that is 9x minus 50. And the amount of money that Li Ting has now will be equals to 8x plus 25 because she received an additional $25 from Bernard. Similarly, Yi Hao also has now 7x plus 25 because he also received $25 from Bernard. Now that we have sorted this out, how then do we go about solving the question to find out the amount of money that Bernard had? Observe that we have not yet made use of the ratio of 16:17:15. So we know that this ratio will follow for these amounts over here, whereby Bernard has 16 units, Li Ting has 17 units, and Yi Hao has 15 units. However, we are not able to have a 3 quantity fraction, although we can have 3 quantity ratio. So what we could do is to just take any two, okay, of these amounts. So either take Bernard and Li Ting, or Bernard and Yi Hao, or Li Ting and Yi Hao, and form a suitable equation with the quantities that's given in this ratio. So what I have decided to do is that I take 9x minus 50, which is Bernard's value, and 8x plus 25, which is Li Ting's value, and form a fraction like that, and then equate it to the ratio of 16:17 based on what is given. So the numerator is all the quantities related to Bernard, and in the denominator, it is quantities associated with Li Ting. Then we know how to cross multiply this equation and achieve 17 times 9x minus 50 and equals to 16 times 8x plus 25. We continue to expand and simplify the equation, and in order to arrive at finding the value of x, okay, so we will get that x equals to 1250 over 25, and that leaves us with 50. Okay, so the amount of money that Bernard had is 9 times of $50, okay, because that is 9x over here, and that is equals to $450. My apologies that the animation didn't come out in a sequential manner. We do write x equals to 50 first before writing the rest of the words. Okay, so alternatively, instead of expressing Bernard to Li Ting, we could definitely choose other forms of expression. So I could consider having Bernard, okay, versus Yi Hao. So that will actually look like that. Otherwise, we could also consider having Li Ting versus Yihao, which will give us an equation looking like this. Okay. Also, we can consider Yihao versus Li Ting the other way around, or Li Ting versus Bernard, okay, or else who else? Yihao versus Bernard. Okay, so we could also flip it around. It doesn't quite matter. Our value, if you go ahead and try it on your own, okay, is that Bernard will have $450 at the start. Let's take a look at how ratios can be applied in real-world context. So Joyce's class sold orange juice at the school carnival. To prepare the orange juice, her classmates mixed 5 liters of orange syrup with water. So that is according to a dilution ratio of 1 part syrup to 3 parts water. The orange juice was sold at $1 for a 200 milliliters cup. In part I, we want to calculate the amount of money that they collected if all the orange juice was sold out. Okay, so we know from the question that the syrup to water ratio is in 1:3 because 1 part syrup to 3 parts water. Since we have 5 liters of orange syrup, that means that if I have 5 parts or 5 liters of syrup, I will require 15 liters of water. So I multiply by 5 across in the ratio given. So what this means is that since I have 5 liters of orange syrup, I'm able to produce a total of 5 plus 15, and that is 20 liters of orange juice. So take note that the juice comes out from adding both the syrup and the water quantity together. So what this means is that since 20 liters is equals to 20 times 1000 or 20,000 milliliters, with 200 milliliters being sold at $1, I can find out that 20,000 milliliters will be 1 divided by 200 times 20,000, or you could see it as multiplying by 100, okay, on both sides of this quantity to get $100. So eventually, we will get that they will collect a total of $100 if they sold out all of the orange juice. Moving on to take a look at part 2, we are told that after the carnival, Joyce commented, "We could have doubled the amount collected during the sale by mixing the orange juice with water in the ratio of 1:6. So from the original of mixing ratio of 1:3, she now proposes 1:6 in order to collect double the amount. We want to think whether Joyce is correct and explain our answer. So in this question, our dilution ratio is in the ratio of 1:6. That will mean that if I have 5 liters of orange syrup, I will require 30 liters of water, such that my total amount of orange juice produced is a total of 5 plus 30 equals to 35 liters of orange juice. So with 35 liters of orange juice, okay, because earlier on, if you were to go back, we saw that we had 20 liters of orange juice, and 20 liters of orange juice will give us $100. And now because we have 35 liters of orange juice, which is not double the amount of 20 earlier on, therefore, logically speaking, we will not be able to double the amount of money collected. So we explain by saying that since the amount of orange juice produced is not doubled from the initial 20 liters, the amount of money collected will not be doubled with the new dilution ratio of 1:6. I hope that you're able to understand the ratio topic so far before we move into rate in our next section.